Welcome to day 81. Today, we're going to pull back the curtain on the one technique that turns a raw, knowledgeable language model into a genuinely helpful assistant.
First, let's start with a puzzle, a paradox I like to call the unhelpful genius. It really gets to the heart of why this whole thing is so necessary.
So imagine you've done it. You've pre-trained a large language model on pretty much all the text humanity has ever created. It's learned grammar, facts, all these complex linguistic patterns. But then when you ask it a simple question, the response can feel bizarrely useless. Why on earth does that happen?
Okay, here's the problem in action. A base model, right, its only job is to predict the next likely word. So it might see the prompt, teach me how to bake bread, and just complete the sentence with something like, in a home oven. It's grammatically correct, sure, but it totally misses what you actually wanted. Now, a tuned model, it understands you gave it an instruction and gives you a useful step-by-step answer. That's the gap we need to close.
So the big question is, how do we get from that first unhelpful response to the second useful one? By the end of this, you'll understand the exact process that makes that incredible leap possible. Let's build up our intuition for this. The trick is to think of it less like adding new knowledge and more like teaching the model a completely new skill. The best analogy I found is to think of a pre-trained LLM as a brilliant student. I mean, this student has read and perfectly memorized every single textbook in the library. Their head is just brimming with facts and information. The problem is, they've never been taught how to take a test. They don't get the idea of a question or how to give a structured answer. So let's break that journey down into 4 steps. Step 1, that's pre-training. This is where the model becomes our genius by absorbing all that text. Step 2, a user comes along and gives it a clear task. But in step 3, we see the failure. Because its only goal is next word prediction, it doesn't actually do what you asked. And that brings us to the solution in step 4, a brand new training phase where we show the model thousands and thousands of examples of good instructions paired with good answers. We're literally teaching it the skill of being helpful.
All right, now let's put a formal name on this process and take a look at how it actually works under the hood.
This whole training regimen is called instruction tuning. It's a specific kind of supervised fine-tuning. We take our pre-trained model and we just keep training it, but this time on a very specific curated dataset. The entire goal is to make the model better at following instructions it has never seen before, which in the field we call a zero-shot setting.
You know, the structure of the training data is incredibly simple. It's really just a pair, an instruction, and an ideal output. So, for example, the instruction could be, translate this sentence into Spanish, and the output would be, well, the correct Spanish translation. By seeing enough of these simple pairs, the model starts to learn the general pattern of how to respond to a command.
This whole idea really gained a lot of traction back in 2021 with a paper from Google Research. They introduced a model called FLAN, that's F-L-A-N, which stands for Fine-Tuned Language Net. This work was a real landmark because it was one of the first to systematically show just how powerful this simple technique could be for improving a model's general abilities.
And in one of their studies, they tested different ways of formatting the training data. Turns out, just giving the input and output, it didn't work that well. Adding a task name helped a bit, but framing the task as a full natural language instruction, that gave a huge performance boost on tasks the model had never seen. This proved that the instructional format itself was the secret ingredient. Now, a powerful extension of this is something called chain of thought tuning. In this case, the target output doesn't just give you the final answer, it actually includes the step-by-step reasoning for how it got there. This teaches the model not just to answer, but to show its work, which is super effective for things like logic puzzles and math problems.
So, where is this technique actually used in the real world? The short answer is, in pretty much every chat-based model you've ever used.
Seriously, if you've used an open-source chat model, you've used an instruction-tuned model. Models like Llama 2 Chat, Alpaca, Vicuna, they all depend on this technique to turn their powerful base models into conversational assistants. It's become the standard way to create useful, interactive LLMs.
The data for all this tuning comes from 2 main places. First, you can have humans write high-quality instruction and answer pairs, like in the DALL-E dataset. This gives you amazing quality, but it's really expensive and slow. So, the second method, which is really common, is to use a powerful, closed-source model like a GPT-4 to generate thousands of examples that you can then use to train a smaller, open-source model. It's a kind of teacher-student dynamic. But this brings us to a final and really important point. What are the limits of this technique? What isn't it doing? Well, when we use one model to generate data for another, we can run into a subtle problem.
The student model gets really good at imitating the teacher model's style of answering, but that doesn't necessarily mean it's gaining any deeper reasoning abilities. It learns to sound helpful, which is just not the same thing as actually becoming more capable.
So here's the key takeaway. Instruction tuning doesn't give a model new knowledge. Instead, it teaches the model how to access and present the knowledge it already has in a useful instruction-following format. It's the bridge that turns a database into a collaborator.